This video is going to go over the basics of quadratic functions. That's the first lesson from chapter 3. It kind of sets the tone for the entire course, so it's a pretty important one. So starting things off, our title is Intro to Quadratics. So it's going to be 3.1.1. And just to help simplify things, we've got a little bit of a vocab sheet here, which you'll be able to find attached to this video. And we're going to fill this out and then kind of compare these terms and see what they mean in the context of our quadratic equations. So some of this stuff is going to be review of what you would have learned in Math 10. Some of it's going to be new. We'll see how we go. First up, we've got polynomials. So a polynomial is either one term or it's a sequence of terms which are all separated by either addition or subtraction. But to be a little bit more specific, all of those terms have to have exponents that are whole numbers. So we don't want negative exponents, we don't want fractional exponents. That also means no variables on the bottoms of fractions or no variables inside of roots. So some really basic examples of those might be something like x squared plus 6x plus 5. Right, so three terms separated by addition. Can be something like 2x minus 8y. So we can have different variables, whatever. Next up, we've got degree. So degree is a way for us to organize our polynomials based on their size, so we can get things in order. It helps us to make sure that everybody writes things in the same way. So for a single term, something like this x squared up here or the 8y, to find our degree, we just take all of the exponents and we're going to add them up, but only the exponents on the variables. So it is the sum of the exponents of the variables. So if we had something like, say, 3x squared y to the power of 4, that's one term, and our degree for that one term would be 6, because it's just 2 plus 4. For an entire polynomial that has multiple terms, we don't add up all of the degrees of the individual terms, it's just the biggest degree for any one of those terms. So if we look back up to our example earlier, that x squared plus 6x plus 5, x squared has a degree of 2, 6x has a degree of 1, and 5 has a degree of 0. So the degree of the entire thing is 2 because it was the biggest of any of those things. A function is any kind of relationship between variables or quantities where a specific input gives a specific output. So basically, if I put something into it, I should always know what I'm going to get out. We covered those a lot last year. This year, we're going more specific. We're looking at quadratic functions. And a quadratic function is a function that has a degree of 2. So it's going to be a lot of squares, x squares, y squares, whatever. No cubes, no other weird things. And we are going to spend a lot of time looking at quadratic functions in this course. They pop up in pretty much every single chapter except for one or two. Our next box there is the shape obtained by graphing a quadratic function. So I'll show you the shape, and then you might know what the name is, you might not. So if we were graphing any sort of quadratic function, we're going to end up with a graph that's going to have this sort of shape. It might be shallower or steeper or wider or whatever, but it's going to look something like this. And this shape is called a parabola. And so the rest of this sheet, you see down here, is just looking at different characteristics of parabolas that we're going to see when we're dealing with a lot of quadratic functions. Some of them are really obvious, like this first one here, direction of opening. So you can probably figure it out what that means. Our parabolas are typically always going to either open up, like this one that you can see up here, right? Those arrows are pointing upwards. It gets wider as it goes up. Or they're going to be opening down. For us, they are not going to be opening to the left or the right because those aren't functions. Next up, we have the vertex. So the vertex is, we can think of it in a few different ways. It's the middle of the parabola. It's where the parabola flattens out and switches from going down to up. It's going to be either the lowest point or the highest point, depending on which direction the parabola is opening in. So if we look at this example that we've got here on the right, our vertex is this point right here. So it's our bottom in this case. It's where our parabola has stopped going this way and started going that way. And you're always going to find it in the middle. Next up, some more pretty self-explanatory ones are maximum and minimum values. So they are going to be the largest and smallest, specifically y values. We don't really care about the x values in this case, only looking at the y values. One of those, if you look at this graph up here, right? So thinking in terms of y, remember y is vertical. So on this particular parabola, you can see that the lowest value of the graph, I don't care about the axes, focusing just on the actual curve here. So the lowest point on that curve is actually our vertex. And that's going to be pretty consistently the case. Unless you have a parabola that's been cut off for a word problem or something, your highest or lowest point, one of them is always actually going to be at the vertex. The other one, most of the time, again, unless you're dealing with a case where it's been cut off, is either going to be, well, we got arrows here. They go all the way up, which means our highest point is infinity. If it was reversed and it was pointing down, like, say, a parabola like this one goes down forever, so it goes to negative infinity. So it's either positive or negative infinity, depending on what your parabola looks like. Next, we've got the axis of symmetry. So hopefully you know that symmetry means a shape that has sort of equal sides that are mirrored with each other. And if you look at a parabola, they are symmetrical. So the axis of symmetry is just the line that goes down the parabola and splits it into two sort of equal mirrored halves. So if you look at this parabola on the right here, that dotted line would be our axis of symmetry. So we split it into two mirrored halves is what we'll say. And it's always going to be a vertical line. It's always going to go through the vertex, because remember, the vertex is in the middle. And if we're talking about it, we're always going to write it as an equation. So hopefully you remember from last year and even in grade 9, vertical lines have the equation x equals something. So this gap here isn't actually when we're going to fill in. That's just going to be whatever it happens to be. So it's the x coordinate of your vertex. We'll see some examples in a bit. Next up, we've got x-intercepts. So you would have spent some time looking at y-intercepts last year when you were dealing with slope-intercept form, y equals mx plus b. X-intercepts, same idea. Those are the points where our parabola crosses the x-axis. So if we're looking back up here, that would be this point and this point. So you can see in this case there are two. That's not always going to be the case. Sometimes you'll have 0, sometimes you'll have 1, sometimes you'll have 2. It depends on where your vertex is and which direction your parabola is facing. So you can see that down here. It says there can be 0, 1, or 2. Those x-intercepts are also called zeros or roots. So you need to know those names too. People use them fairly interchangeably, but sort of for different reasons. Next up, y-intercept. Same idea, except it's where we cross the y-axis. There's pretty much always going to be 1. The only exception would be, again, if it's a word problem where something's got cut off. We don't care as much about y-intercepts when it comes to parabolas. They're not as useful, so you won't see them as much. And then our last two down here, we have the domain and the range. So we spend a lot of time on these in grade 10. They're back again in grade 11. Domain, you'll hopefully remember, is the set of all the possible x values of your function, in this case of your parabola, and range is all the possible y values for your function. And so we'll see how those work when we're dealing with parabolas. It's pretty much the same as last year. All right, so that's it for the vocab sheet. Let's try actually putting this to work now. So we're going to try a couple of examples, a few different functions, and see how they look. So first up, to keep things simple, we're going to graph the most basic of parabolas. So we are going to try graphing y equals x squared. So remember, x squared, like I said, quadratics are always degree 2, so you're going to have a square in them. So go ahead, sketch yourself out a grid. In this case, we're going to draw one that goes up to 10, down to -10, and then same for left and right. So go ahead, pause this video right now, draw yourself a grid, come back once you're done. All right, so now that we've got our grid all set up, we can go ahead and draw ourselves a parabola. A couple of quick reminders before we get into that. Remember, when you're drawing your graphs, make sure that you've got arrows on your axes. Make sure you label those axes. So in our case, that's x and y. And make sure your numbers are spaced out correctly. So for us, we want to graph y equals x squared. We will get to a point in this course where we'll be able to graph this really quickly. It'll take maybe 10 seconds. We're not there yet, though. So for now, just to get ourselves going, we're going to go with the classic table of values. So we'll draw ourselves a little table here off to the side. So that's x and y. And typically, for a parabola, we want to have usually around 5 points. 1 is useless, it's just a point. 3 is still too few most of the time unless our parabola is really big. 5 is a sweet spot. In this case, we're going to go a little bit further, and we're actually going to do 7 points. So we're going to use the x values -3, -2, -1, 0, 1, 2, and 3. And so the same way you would have done in grade 8 and grade 9 and grade 10, we're just going to take these x values, we're going to plug them into our function, and we're just going to get some values out. So I'm just going to slide over here for a sec. So if we take y equals x squared, and we plug in those x values, like say -3, we'll have y equals -3 squared. And so -3 squared is -3 times -3, which is +9, not -9. Remember, a negative times a negative is a positive. So when x is -3, y is 9. And so we repeat the process. We can do it mentally. If we plug -2 in there, -2 times -2 is +4. -1 times -1 is +1. 0 times 0 is 0, and so on and so on. So we get 1, 4, and 9. So those are our 7 points that we're going to use for this particular parabola. So let's head on back over to our graph and plot those down. So we've got -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And so if you look at those points, you can already see the parabola shape there. And you can see some symmetry going. So important things when you're drawing parabolas, there's a few things that we really don't want to see. It's important to remember that a parabola is a smooth curve. So it's going to be hard to do at first. You'll have some shaky lines, but you want something that's going to end up looking something like this. So this is the one side. We can see it's curving down. And then we go the other way. And there's different strategies that people use. For me, I actually usually end up rotating the page. So I'm always kind of drawing downwards, even when I'm doing the upwards part. We get something that looks like this. The right side's not amazing, but it'll do. And so this is our parabola. So if we go back and we think about that vocab sheet that we had before that had all of those different criteria on it, there's a few things that we can spot here. So our direction of opening, this one is definitely opening upwards, right? We can see we got the arrows up here at the top. It's going up. Our vertex is down here at the bottom. So this spot right here, this is our vertex. It's where the parabola stops going down and starts going up, depending on your perspective. Our maximum and minimum values. So our minimum value is down here, and we'd say our minimum is y equals 0. It's the lowest the graph gets, which again is just the vertex. Our vertex is 0, 0, so those two numbers are the same for a reason. Our maximum value in this case, since we've got those arrows at the top, that means that we just keep going upwards. We don't really have a maximum. So we'll just say our max is infinity. It's the highest we get. Our axis of symmetry, so we can think of a dotted line coming down through the middle of this parabola. going through our vertex gets us our two mirrored halves. And so for our axis of symmetry, remember we want to write it as an equation. So it's not just 0, it's x equals 0. So it's our x-coordinate of our vertex now, rather than our y-coordinate. So you see that and that are connected. Our x-intercepts, in this case, there is only one, so, which also happens to be our vertex. This particular parabola is pretty boring. So our x-intercepts is just going to be 0. Not that there are 0 of them, but it is at 0. You can also write that as a point if you'd prefer, but it's not necessary. Y-intercept is also at 0. And then our domain and our range. These are things that people do tend to struggle with a bit. So with domain, remember you're describing all of the x values of your graph. For me, as long as it's in one piece, which essentially everything we're going to do in this course will be, what's often easiest to think is how far left is the graph going, how far right is the graph going? What are sort of your boundaries? So in this case, if we look back at the graph, those two arrows at the top, they do seem to be going upwards, but they are also going outwards. Our parabola is going to go left forever, and it's going to go right forever. It's going to go up a lot faster than it goes left or right, but it is still going outwards. So we don't actually have any boundaries or barriers when we're thinking in terms of horizontal values, in terms of domain. So thinking back to last year, if we don't have any restrictions, we'd say our domain would be all real numbers, or the proper way to write that is x, because it's x values, and then this weird looking e, and then this weird looking r, which means x is in the set of real numbers. Our range, on the other hand, is not all real numbers. So if we go back up to the graph again, we can see the graph does go up forever, right? We've got those arrows up at the top. So we are going up forever and ever, but it doesn't go down forever. It does have a bottom. So the vertex is the bottom of our graph. It is our lowest y value. That's why it's our minimum. And so when we're talking about our range, if we're looking at where the graph is, we'd have to say the graph has to be above that minimum value. So for our range, we're going to say y, because it's the y values, is bigger than or equal to 0. So it's always going to be y, and the number should typically be what your minimum value was or your maximum value, depending on which way you're going. For the symbol in the middle, you just got to think, do I want to be bigger than this number or smaller than this number? All right, and so that is an example of a parabola, fully broken down with all of the characteristics. So a few things about graphing parabolas. They always have the same general shape, but there are some differences. So all of our quadratic functions have the same general shape. So similar to the ones that we've already seen, you might have something that looks like this. Or you might have something that's maybe facing downwards, maybe it's a lot broader, right? So it opens more slowly, but it's still a parabola. Or you might have something really skinny, something that goes up really quickly. And you'll run into all of these throughout this course in different situations. But they're all parabolas. But some things to notice. Again, they're all smooth curves. They all look roughly the same. They've all got symmetry. So a few notes for things that we don't want to see, things that don't make parabolas. I'll make this colorful so it stands out a bit. First, when you're drawing your parabolas, there are no corners, we'll think of them as points. Yeah, there's points in terms of math, but it's not pointy. So this is bad. You see that really sharp point down there at the bottom. We don't like that. It's also not a V shape. Okay, so there are no straight lines like this. It's got to be curving. Next, we don't want to have any sort of weird bends or curves. So keep in mind what a parabola looks like and make sure whatever you end up with has sort of that same general shape. So I'm thinking things that look like maybe this, where you see where it stops going up and it starts to flatten out again. That's not what a parabola looks like. And then we also don't want any vertical lines. So it's not really a U either. So I'll see something like this fairly often where it just goes straight up or straight down. All of these things are no good. We do not want them. They are bad. Do not do. All right. None of these make proper parabolas. So we're going to try this out again, but with a different, slightly more complicated question now. So we're going to determine the characteristics of the graph. And when I say characteristics, I mean those same things like maximum and minimum, direction of opening, vertex, all of that. So you're going to want to copy this down. So sketch out a grid, copy down the graph, and then once you're done that, go ahead and pause the video, answer it for yourself, and then come back and see how you did. So don't mind me as I get my grid out. All right, so 10 by 10 again, and here are the points that you're going to want to get down. So we're going to have points at -4, -9, so right there, -5, -8, and -3, -8, -6, -5, and -1, or sorry, -2, -5, and then 0, or sorry, -7, 0, and -1, 0. And then lastly, -8, 7, and 0, 7. So all of those points there, go ahead and copy all of those down. Do your best to draw a nice looking parabola through them, keeping in mind all those things that you don't want to see. And then once you're all said and done, go ahead and pause the video and start figuring out all of these different characteristics that I'm going to write down here. So we're going to have our direction, our vertex, our maximum value, our minimum value, axis of symmetry, x-intercept or x-intercepts, y-intercept, and then lastly your domain and your range. Okay, so go ahead and pause here. Come back once you're done. All right, so if we're going to draw a curve through our parabola, again, wanting to make it look as good as possible, don't hold yourself to perfection. I've been doing this for years, and mine still don't look great all the time. You can see I got a little bit of a shimmer on the side. It's okay. I'm not going to hold that against you. But just do your best. If you slightly miss a point, that's okay. But sometimes you do got to go back, like you see I did there, and maybe just give it a slightly better run through. All right, there we go. So there's our parabola. And so if we're going to look at those characteristics that we've got, let's see what we can come up with. So our direction, again, this one's pretty clear. It's going upwards. Our vertex is this point way down here at the bottom. So when we're answering vertex, we're just going to answer it as a coordinate. So remember, that's going to be bracket your x value, which in this case is -4, and your y value, which is -9. Your maximum value. So looking at our graph, it's going upwards. it goes up forever, so it goes all the way up to positive infinity. Our minimum value is at the vertex. It's the farthest down the graph goes. So our lowest value is our y value from the vertex, which is going to be -9. Our axis of symmetry is this dotted line, comes down through the middle of the parabola, crosses through the vertex, and is just going to be the x-coordinate of that point. So that is x equals -4. Our x-intercepts, well, we've got 2 of them. So those are these 2 points right here and right here. And so we can just write down those x values. It's just -1 and -7. Make sure you don't put those in brackets because we don't want them to look like a coordinate. Our y-intercept is this point right there. So that's just at y equals 7. So you can write it as 7 or as a coordinate. It's up to you. Domain is all real numbers again. Graph goes left forever, graph goes right forever. So it's just x, weird looking e, weird looking r. Then for our range, the graph goes up forever. So we don't have a maximum value, but we do have a minimum. We've got that -9. So it's y, it's -9. And then you just want to think, well, do I want to be above that value or below that value? Greater than or less than? In this case, we want to be above -9, so we're going to use the greater than. And pretty much always we're going to want to include the equals part as well. All right, so we're going to do one more of these, but we're going to mix it up a bit, and we're going to do one that doesn't go on forever like the last couple that we've seen. So I'm going to sketch out one more for you to do, and then we'll go from there. This one is not going to go up, down, left, and right. It's just going to go up and right. And we'll mix up the numbers a bit. So instead of going up by 1s, we're going to go up by 10s. So that's going to be 0, that's going to be 50, that's going to be 100 on our y-axis. But we'll stick with going up by 1s horizontally. So that'll be 2, 4, 6, 8, and 10. So here's our graph. And I'll give you a few points to throw on there as well. So we're going to have one at 75, so 0, 75, 2, 100, 4, 75, and 6, 0. So go through and repeat the same thing that we just did. Just draw a curve through that, write down all your characteristics, your domain, range, etc., etc., and then see how you did. So I'll come back in a couple minutes and compare your answers. Okay, so your parabola should hopefully look something like this. Well, maybe a little better than that, actually. This would be something that we might see for a word problem, whether it's maybe somebody throwing something or something being shot into the air. Parabolas, you'll find out, have a lot of things in common with physics questions. There's a lot of overlap there. All right. So, setting things up. Our direction. In this case, this parabola is actually pointing down instead of up, unlike the last couple. Okay. So think of it as if you were modeling with your hand. Would your hand be pointing at the ceiling, or would your hand be pointing at the floor? Our vertex. Well, it doesn't really look necessarily like the middle anymore because the parabola has been cut off a bit, but hopefully you notice that it is at 2, 100. It's where the parabola has stopped going up and started going down. Our maximum, our highest y value, although it might not be y, it might be h or something. Our maximum is at 100. Our minimum, in this case, is at 0. There's nothing down here in the negatives. Our axis of symmetry is at x equals 2. So remember, it goes through the vertex. Our x-intercept, we only have 1 in this case, even though if this one did get drawn fully, it would have 2. We can only see 1, and the one that's kind of over here on the left side doesn't exist. So our x-intercept is just at 6. Our y-intercept is at 75. And then the domain and the range, those are the tricky parts. So our domain isn't going to be all real numbers in this case because the graph doesn't go forever. Our smallest x value is 0. Our biggest x value is 6. And we can be anything in between those. So a quick refresher on how to write those. When you're in between two things, your domain or your range should look something like this. It's your smallest value, your variable, your biggest value, and then those two symbols, right? So you want to be bigger than your smallest value, but smaller than your biggest value. Our range is going to be basically the same thing, where our smallest value for our range is also 0. Our biggest value for our range is 100, and we want to be between those two things. So there we go. That is quadratic equations. It's a really important concept that we're going to see a lot, so make sure you got a handle on this, and we'll see you in the next one.